Pre-Calc 11, Chapter 8.1. We're going to be looking at absolute value functions. The syntax is y equals a straight line, a long straight line, f of x, and another long straight line. And we need to treat the parameter, whatever's in between the straight lines, as brackets for order of operations. And one way to express absolute value functions is using a piecewise function. So we have x if x is greater than or equal to 0. We have negative x if x is less than 0. Now, if we're going to have a function, then we have f of x if f of x is greater than or equal to 0. Or we'll have negative f of x if f of x is less than 0. So in real life, we have absolute value functions. So if we're taking something like distance or length, those cannot have negative values. They're defined to be positive values. So here's an example. Write as a piecewise function, y equals the absolute value of 2x minus 7. Now, we need to find out where 0 is to know what the positive values are and the negative values are. So we just solve for this. 2x minus 7 is less than 0. 2x is less than 7. We bring the negative 7 over the other side, it becomes positive. Divide both sides by 2, so we have x is less than 7 over 2. So here we have y equals, and we write the piecewise function. It's equal to 2x minus 7 if x is greater than or equal to 7 over 2. And it's equal to minus, and put brackets around the whole thing, if x is less than 7 over 2. Here's a slightly harder example. We have a quadratic. Y is equal to the absolute value of negative x squared plus 2x plus 15. So let's solve for the negative case. Negative x squared plus 2x plus 15 is less than 0. Let's make the left side negative. So we have x squared minus 2x minus 15. Now we have greater than 0. Whenever we multiply by or divide by a negative, we have to flip the sign. X minus 5, x plus 3, greater than or equal to 0. So we can see that all the stuff that we did in the previous chapters, we're using again. So we're using inequalities again. We're using factoring again. And since this is concave up, and we're looking for greater than 0, it must be the outer interval. Outer interval. So we have x is less than negative 3, or x is greater than 5. So let's write our piecewise function. Y equals, and we need 3 lines. It equals negative x squared plus 2x plus 15 if x is less than negative 3. Okay, so we need to take the negative of this function because we found out where our negative intervals are. And now we just have the positive case. If it's going from negative 3, it's less than or equal to x, it's less than or equal to 5. And again, we have negative x squared plus 2x plus 15 if x is greater than 5. So graphically, this is a more complicated function. It doesn't matter what it is. It's at least a quartic function. We don't have to worry about that. All we need to do is reflect on the x-axis any intervals of negative values. So we need to know where the zeros are. We have 0, 0, 0, 0. This interval is negative, so we do our best to approximate the reflection. And here we have a negative interval. And again, we do our best to approximate the reflection. Okay, so this is our absolute value of that function. Here's another one. This time we're not given the graph, we're only given the function. So what we need to do is factored form. And we need to get the x-intercepts. So we're looking for minus x minus 4 squared plus 4 equal to 0. Okay, what we'd like to do is expand this. Minus x squared minus 8x plus 16 plus 4 equals 0. So we distribute the negative sign. This is minus x squared. We have minus negative 8x, so this becomes plus 8x. And we have minus 16 plus 4, this is minus 12. And we multiply the whole thing by negative 1. So we have x squared minus 8x plus 12 equals 0. Now we factor this. So we need factors of 12 that add up to negative 8. So this is x minus 6, x minus 2. So we have x equals 2 or x equals 6. We can graph this one. We have the coordinates 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Remember, this is the vertex form. We go 1 over, 3 down, and then 5 down. 1 over, 3 down, and then 5 down. So it looks something like this. Something like that. We can reflect this point. This is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it looks like this. And our absolute value function looks like that. We want to reflect intervals of negative values. So let's look at how we do this on the calculator using the TI. Okay, let's plot negative x minus 4 squared plus 4. And then we can do absolute value. This is under math and under number. So we go right one and then absolute value. And we can just enter it again, negative x minus 4 squared plus 4 and graph. Okay, it's hard to see that. So we go back to y equals. We go over to the left and make that a thick line and then graph. So we see the absolute value function. We see the original quadratic as well. Let's look at the Casio. Okay, we do the same thing, negative x minus 4 squared plus 4. And I don't remember which one it is, so you can always go list or catalog, and absolute value is near the top, and then use brackets, negative bracket x minus 4 squared plus 4, and another bracket for the absolute value. And we want to go up here, we want to change the style, and we want the thick line. And execute. Okay, and the window is not right, so we'll switch to standard and draw. And it looks somewhat similar to that. Okay, that's how we use the calculator. Remember, shift, catalog. Here we use math. We scroll over one, and we get the num, and we can get absolute value. One last problem. You're given the 2 points. Determine the absolute value of a linear function such that the x-intercept is between -2 and 3. So here we're given 2 points. The x-intercept is somewhere in between. We can draw this out. It should have the same slope. Okay, so this is the negative slope of this. And the way do we get the actual functions? We just continue them along. And we can continue this one along. Okay, this line has a y-intercept of 1, and the slope is negative. So y equals negative x plus 1. And this line has an y-intercept of -1, and its slope is just 1. So y equals x minus 1. And since we're looking for the absolute value function, we just put absolute value around that one. We put absolute value of that one. And either of these ones will give you that as your absolute value function. And that completes this lesson.